Okay, this is the video ghost lesson of the 5-4 notes. They're very similar to the 5-3 notes, which were over the sum and difference identities for cosine. In this section, we'll be doing sum and difference identities for the other two basic trig functions, sine and tangent. Now, we're just going to give those identities, and then we'll talk about how we use them throughout various problem types. There are some examples in this section that are actually helpful for the homework from the previous section. These two sections are very closely related to each other. So the sine of a plus b, the identity for that states that the sine of a plus b is equal to the sine of a times the cosine of b plus the cosine of a times the sine of b. Now that's very similar to the difference identity for sine. In fact, the pattern of sines and cosines is exactly the same. It starts off sine of a, cosine of b. The only difference is that there's a minus sign in the middle. So it would be minus cosine of a, sine of b. Now we're going to need our unit circle. You'll notice I have it open up here at the top, ready to go to whenever I need it. I'm going to post that document as well with this video and the notes and the homework once I get done recording it. Now if we take the sine values and the cosine values from the previous section, that would allow us to find tangent, because tangent of any angle is sine over cosine. So what we could do is take that sine of a plus b and put it over the cosine of a plus b, and that would be the tangent of a plus b. And we could go through that entire derivation. I could do it right now. But it's not really vital that we understand exactly where the identity came from as long as we are using it correctly. At least not in this course. So the tangent of a plus b, when we do that process and we clean it up as much as we can, is the tangent of a plus the tangent of b over 1 minus the tangent of a times the tangent of b. And much like the sine identities and the cosine identities, the difference and sum identities are very similar. In fact, it is exactly the same pattern, except the signs are reversed. So it would be tangent a minus tangent b, not a, tangent b, over 1 plus the tangent of a times the tangent of b. So we now have a total of 6 identities here that we are going to be using to solve problems. The sum and difference identities for sine, the sum and difference identities for cosine, and the sum and difference identities for tangent. Now the examples in this section stick to sine and tangent, but these same exact problem types could appear in our cosine section. So we need to be prepared for that. Okay, so again, we're doing these problems where we're finding an exact value without using a calculator. 75 degrees is not on the unit circle. However, we could write this as the sine of 30 plus 45, and both of those angles are on the unit circle, just like we did in the last section with the cosine. So what we're going to do is we're going to follow our pattern for the sine of a plus b. Now it doesn't have to be 30 and 45. There are other values you could use that subtract to 75, for instance. As long as the two values you use add or subtract to 75, we have a pattern for that. So for the sine of a plus b, we're going to follow our pattern, which was sine a cosine b plus cosine of a sine of b. A in this case is 30 degrees, B is 45 degrees. So our next step would be to write this expression as this pattern. So that'd be sine of 30, cosine of 45, and those are degrees, plus cosine of 30, sine of 45. Now this is where we go to our unit circle, because we need to know the sine and cosine of 30, the sine and cosine of 45. So on your unit circle, and you'll notice we've added the tangents around the outside since the last time that we used it, we are looking at these points, and the points are the cosine and the sine of each angle. So for 30 degrees, the cosine is root 3 over 2, the sine is 1/2, and for 45 degrees, the cosine is root 2 over 2, and the sine is root 2 over 2. So we go back over here to our notes, and we replace these values with the values from the unit circle. The sine of 30 is 1/2. Cosine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Sine of 45 is root 2 over 2. Then all we have to do is simplify this expression as far as we can. So we start by multiplying each pair of fractions, top times top, bottom times bottom. So we'd have root 2 over 4 plus root 6 over 4. Then we want to combine these two fractions, which means we need a common denominator. Oh look, we've already got one. Perfect. So all we have to do is combine them by writing that sum as the numerator, root 2 plus root 6 over 4. Our answer will not get any better than that. Alright, here's another one. Now we've got tangent of 7 pi over 12. So the first thing I'd suggest you do if you're not horribly comfortable with radians is convert 7 pi over 12 to degrees by multiplying by 180 over pi. That ends up being 7 times 180 divided by 12, which is 7 times 15, which would be 105 degrees. So we could say that this says the tangent of 105 degrees. Now again, when we do that, we just need to come up, that's not on the unit circle. We just need to come up with two values that are on the unit circle that add to 105 degrees. For instance, 60 plus 45. We could also come up with two that subtract to 105 degrees, like 135 minus 30. That would work exactly the same. You'd end up with exactly the same answer. Now, since we're using 60 plus 45, we're going to follow the pattern for tangent of a plus b. The pattern for tangent of a plus b is tangent of a plus tangent of b over 1 minus tangent of a times tangent of b. So we're going to plug in these tangent values for 60 and 45 to get that expression. So that would be, I'm going to write down here on the left, tangent of 60 plus tangent of 45 over 1 minus the tangent of 60 times the tangent of 45. So then we go to our unit circle and we look those values up. Now again, we added those values in class so that we would have them for this very purpose. The tangent of 45 degrees is 1. Again, we got that by doing sine divided by cosine. Root 2 over 2 divided by root 2 over 2 is 1. And tangent of 60, well, that would be root 3 over 2 divided by 1/2, which would be root 3. So the tangent of 60 is root 3, and the tangent of 45 is 1. We're going to plug those numbers in. So that's root 3 plus 1 over 1 minus root 3 times 1. So that would be root 3 plus 1. Actually, I'm going to write that as 1 plus root 3 because that would be the proper math notation. So 1 plus root 3 on top. I just switched these terms to put the whole number first, as is convention in the math community. And down here, I'm just going to multiply 1 times root 3 to get 1 minus root 3. Now, tangent is a unique situation because tangent is a fraction. And in a fraction, according to our rules of algebra, our proper notation rules, we are not allowed to have a square root in the denominator. So we have to do something to get rid of this root 3. Now, I don't know if you remember this from Algebra 2 or not, but in Algebra 2 we learned how to multiply by the conjugate to rationalize the denominator. So we're going to multiply the bottom and top by the conjugate of the bottom. Now when I say conjugate, we just take this binomial and change the sign in the middle from negative to positive. That's the only difference. Now the downside to that is that we then have to FOIL these out. Okay, we have to make sure that everything in the first parenthesis multiplies everything in the second parenthesis. So on top we have 1 times 1, which is 1. 1 times root 3, which is root 3. Root 3 times 1, which is another root 3. And root 3 times root 3, which would be root 9. The square root of 9 is 3. Again, root 3 times root 3 is root 9, which is 3. On the bottom, we have 1 times 1, which is 1. 1 times root 3, which is positive root 3. Negative root 3 times 1, which is negative root 3. And negative root 3 times positive root 3, which is negative root 9, which is negative 3. Then we go in and we add our like terms. So when we do that, positive root 3 and negative root 3 will cancel out. If we're rationalizing our denominator, that should happen every single time. We add the like terms on top. 1 plus 3 is 4. Root 3 plus root 3 is 2 root 3. And 1 minus 3 is negative 2. Now we're almost done. The only problem here now is that we have a common factor in all three terms of our fraction. All three terms are divisible by 2, so we are expected to divide all 3 by 2. And I'm actually going to divide by negative 2 so I can get rid of the denominator in its entirety. So 4 divided by negative 2 is negative 2, and 2 root 3 divided by negative 2 is negative root 3. So our answer would be negative 2 minus the square root of 3. Let's do another one. Okay, now this time they've given us the right side of one of our patterns, and we just have to recognize which pattern that is. So if we look, we have the pattern sine of an angle times the cosine of a second angle minus the cosine of the first angle times the sine of the second angle. So A would be 40, B would be 160. That is the pattern for the sine of A minus B, which means we can rewrite this as the sine of 40 minus 160. 40 minus 160 is negative 120 degrees. Now we've learned already this year that if our angle that we're working with is not in the first rotation, we can simply use a rotation. We can add one rotation to our angle, and it will not change any of the trig values. So this is equivalent to the sine of 240 degrees, because negative 120 plus 360, that angle is coterminal, meaning it will have the same trig values. We go to the unit circle, we find 240 degrees, and we look up the sine, which would be negative root 3 over 2. So our answer should be negative root 3 over 2. Alright, I feel like that tangent one is a bit of a problem, so we're going to do another tangent one just to make sure that we have several tangent examples in our notes. This particular tangent example is not very much fun. So 13 pi over 12, we should start by turning that into degrees. So it's times 180 divided by pi. That's 13 times 15, because 180 divided by 12 is 15. That would be 195 degrees. So this is the tangent of 195 degrees. So we need two trig values that subtract or add to 195 degrees. Now we haven't done any differences yet, so I'm going to use 225 minus 30. Again, it doesn't matter what two values you use as long as both values are on the unit circle and they add or subtract to this number, 195. So in this case, we're going to use the pattern for the tangent of A minus B, which is the tangent of A minus the tangent of B over 1 plus tangent of A times tangent of B. So that would be the tangent of 225 minus the tangent of 30 over 1 plus the tangent of 225 times the tangent of 30. At this point, we go to our unit circle. We find the tangent of 30, which is root 3 over 3. And we find the tangent of 225, which is positive 1. We're going to go back and plug in those values. So, tangent of 225 is 1. Tangent of 30 is root 3 over 3. Over 1 plus, the tangent of 225 is 1. Tangent of 30 is root 3 over 3. Now, this adds another layer of arithmetic difficulty to this problem, because now we're going to have a fraction within a fraction, as well as having that issue with the square roots. So what we need to do is we need to get a common denominator on top and a common denominator on the bottom. So that would be 3 over 3, because that's equivalent to 1, minus root 3 over 3. And then here I'm going to multiply these, which, basically just drop the 1, and then get a common denominator. So that'd be 3 over 3 for that one, plus root 3 over 3. So there we are looking at 3 minus the square root of 3 over 3, and 3 plus the square root of 3 over 3. Now, when we get to this point, we need to get rid of the complex fraction. We've talked about this several times already in this chapter. We're supposed to take the denominator and flip it over. So 3 over 3 plus root 3. Remember, that's in parentheses, as is this. And multiply the bottom and the top of the fraction by that fraction. Remember, there's parentheses. The reason we do this is that causes the entire denominator to cancel, as well as these 3's, and changes our expression into 3 minus root 3 over 3 plus root 3. Remember, you can't cancel here. You're not allowed to. There are parentheses around that. So instead, we now have to conjugate. We have to multiply by the conjugate, which would be 3 minus the square root of 3. And FOIL, just like we did on the earlier tangent problem. So that would be 3 times 3 is 9. 3 times negative root 3 is negative 3 root 3. Negative root 3 times 3 is negative 3 root 3. I know that's hard to listen to, a lot of 3's. Negative root 3 times negative root 3 is positive root 9, which would be positive 3. On the bottom, 3 times 3 is 9. 3 times negative root 3 is negative root 3. Root 3 times 3 is positive root 3. 3 root 3, sorry. And root 3 times negative root 3 is negative root 9, which would be negative 3. Come on. There we go. Now we're going to go in and combine like terms. Again, if we've done this correctly, these two terms on the bottom with the roots should always cancel out, which they do. 9 plus 3 is 12. Negative 3 minus 3 is negative 6 root 3 over 9 minus 3, which is 6. Notice, everything's divisible by 6, so we divide by 6, which would give us 2 minus the square root of 3. These answers are usually going to look very similar to each other. So if you get something outrageous, you probably did something wrong. Alright, let's look at another problem type. Now in this problem type, we're doing something different. What we're trying to do essentially is get rid of the 30 in this expression. We're trying to get it to the point where it is only made up of sine theta. So to do that, we're going to start by applying our pattern for the sine of a plus b. That is what we do first. There are some problems like this on the 5-3 homework as well that use the cosine rules. So we're going to go in here and use the sine rule, sine a cosine b, plus cosine of a sine of b. So in our pattern here, we would have sine of 30 cosine of theta plus cosine of 30 sine of theta. Now that's very similar to what we did before, but we're not done yet. What we need to do now is go to our unit circle and find these two values, cosine of 30 and sine of 30. The cosine of 30 is root 3 over 2. Sine of 30 is 1/2. So that's what we plug in. The sine of 30 is 1/2. So we have 1/2 times the cosine of theta. And the cosine of 30 is root 3 over 2, which is sine theta. Now we can't do a lot with that. Now one thing to notice is that this is actually a fraction plus a fraction. Because even though we're multiplying 1/2 times cosine, that multiplication would cause that to be on top. So we already have a common denominator, and what we can do is we can combine those fractions into a single fraction, which is slightly better, but not much better than it was. But notice there are no longer any 30s anywhere in that answer. So that is the simplified answer. Now a lot of times they end up looking a lot better than that when we're done. So let's do another one. Tangent of 45 minus theta. So we're going to apply the rule for the tangent of a minus b. And I'm having all kinds of little tech issues here. There we go, a minus b, which is tangent of a minus tangent of b over 1 plus tangent of a, tangent of b. We're going to plug those in here into this expression. So this would be the tangent of 45 degrees minus the tangent of theta over 1 plus the tangent of 45 degrees times the tangent of theta, which means we need to go find the tangent of 45 degrees. We go to the unit circle, tangent of 45 degrees is 1. So we go back here and we plug in 1. So 1 minus the tangent of theta, because we put in a 1 for tangent 45, over 1 plus 1 times the tangent of theta, which is tangent theta. That expression is perfectly fine, and it's not going to get any better, so we might as well just keep it. That is the end of the tangent problem. Okay, let's do one more of those. I think in class I had you try this one on your own, but you're not in here to try it on your own anymore. So we're just going to do this one here so that you have this example. You can check your work. I checked it in class, but we'll check it again. Again, we're going to follow our pattern. In this case, it would be sine of a minus b, which is sine of a cosine of b minus cosine of a sine of b. So that would be, for this particular expression, the sine of 180 times the cosine of theta minus the cosine of 180 times the sine of theta. So we need to go locate the sine and cosine of 180. Off to the unit circle. We find 180. Cosine's negative 1. Sine is 0. So back to the work. Sine of 180 is 0 minus the cosine of 180, which is negative 1, times the sine of theta. Now, we can simplify that a little bit further because 0 times anything is 0. So that term drops out. The two negatives make a positive, and 1 times sine is sine. So this is equivalent to the sine of theta. All right. Now for the long problem. Now the only reason that this is a long problem is because of what we needed to know in order to do the problem. Remember, if we're being asked to find the sine of a plus b, that means we need to know the sine of a, the cosine of b, the cosine of a, and the sine of b. And if we're asked to find the tangent of a plus b, that requires us to know the tangent of a and the tangent of b in order to fill out our various identities. Yes? Well, the only two that we currently know, the only two that we are given any information on, is the sine of a, which is 4/5. And my highlighter screwed up again, of course. Sine of a, which is 4/5. And the cosine of b, which is negative 5/13. Now they did tell us a little bit more. They told us that a is between pi over 2 and pi radians. Well, that's 90 degrees and 180 degrees. So what this is saying is that angle A is in quadrant 2. Same thing over here for B. They told us it's between pi radians and 3 pi over 2 radians. That means that B is in quadrant 3. So that's what they've told us. Now they've given us enough information to use the sine of A to find the cosine of A and the tangent of A. And they've given us enough information to use the cosine of B to find the sine of B and the tangent of B. But we're going to have to do some pre-work before we can even start this problem. So, let's start with A. Okay? This is pre-work. Okay? The sine of A is 4/5. From early in the book, we should remember that sine is y over r. That tells us that y is 4 and r is 5. Now we know the Pythagorean theorem applied to one of these pictures of an angle in standard position tells us that x squared plus y squared equals r squared. And if we knew x, we could write out fractions for the cosine and the tangent. So we plug in what we know. We have x squared plus 4 squared equals 5 squared. And we solve for x. So x squared plus 16 equals 25. Subtract 16, x squared equals 9. Take the square root, x is plus or minus 3. Now this is where the quadrant comes in. We're working with A, so A is in quadrant 2. And in quadrant 2, we should know x is negative. So instead of plus or minus x, we're going to say x is negative 3. Now, if x is negative 3, then the cosine of angle A, which is x over r, has to be negative 3/5. And the tangent of A, which is y over x, has to be 4 over negative 3, which are the two values we didn't know that we need to know of A to do this problem. So what we're going to do is we're going to repeat those steps, only we're going to do it with cosine of B to find the sine of B and the tangent of B. So we do the same thing we just did. The cosine of B is negative 5 over 13. Well, earlier in the book we learned that cosine was x over r. Now you might be saying, well, how do we know which one's negative? R is not allowed to be negative, remember? So x would equal negative 5 and r would equal 13. So we're going to plug into x squared plus y squared equals r squared. So that's negative 5 squared plus y squared equals 13 squared. Or 25 plus y squared equals 169. Subtract 25, y squared is 144. Take the square root, y is positive or negative 12. Now again, we have to figure out which one we're dealing with. So we go up here and we say, oh, B is in quadrant 3. And in quadrant 3, y is negative. So y would be negative 12. And if y is negative 12, then the sine of angle B, which is y over r, is negative 12 over 13. And tangent of B, which is y over x, would be negative 12 over negative 5. Those negatives would cancel and leave 12/5. So now we are finally ready to actually do the problem, because now we know all 6 values that we need to know. We were given in the directions that sine of A is 4/5. We used that to find that the cosine of A was negative 3/5. Cosine of A was negative 3/5. And the tangent of A was negative 4/3. We also were given that the cosine was negative 5 over 13. We used that to find that the sine of B was negative 12 over 13, and the tangent of B was 12/5. So we have everything we need to do parts A, B, and C. So we have the sine of A plus B, which we already wrote out once, is sine of A cosine of B plus cosine of A sine of B. And I'm cutting it awful close there, so I hope you can read that. It's the same pattern we've been using all along. So we go in here and we find those values. The sine of A is in the directions. It's 4/5, right there. The cosine of B is in the directions. It's -5/13, plus the cosine of A, which we found down here, it's -3/5, times the sine of B, which is down here, -12/13. So again, we've done a problem like this before. We're going to multiply these two fractions, multiply these two fractions. That's -20/65 plus 36/65, which is 16/65. So the sine of A plus B is +65, and that sign is going to matter on part C. In part B, we're asked to find the tangent of A plus B. Now the tangent of A plus B is the tangent of A plus the tangent of B over 1 minus the tangent of A times the tangent of B. So that would be tangent of A, down here, is 4/-3, so 4/-3, plus the tangent of B, which is 12/5, over 1 minus the tangent of A, which is 4/-3, times the tangent of B, which is 12/5. Now there's a lot going on here, but arithmetically what needs to happen is I need to add the fractions on the top, which is going to require a common denominator, which would be 15. So we're going to multiply the first fraction by 5. That would be 20/-15. Well, let's do -20/+15 because we can. And the second equation we're going to multiply by 3. That would be 36/15. And on the bottom we're going to multiply these two fractions together, which would be, these negatives would cancel, so we'd have plus 48/15. And we're going to go ahead and get a common denominator by rewriting 1 as 15/15. Because our next step will be to add these two fractions together. So that would be 16/15 on top and 63/15 on the bottom. Fraction within a fraction. We should know exactly what to do, and that is multiply by 15/63. The 15s would cancel on top, and the entire bottom would cancel. That's the whole point of doing that. And that would give us an answer of 16/63 for our tangent of A plus B. So the sine of A plus B was a positive number, 16/65. And the tangent of A plus B was 16/63. The reason I mention those, that they're both positive numbers, is because the third part asks us to figure out the quadrant in which A plus B terminates. Well, our sine of A plus B is positive, and our tangent of A plus B is also positive. Now back in a much earlier part of the semester, we came up with the signs of our trig functions based on what quadrant they're in. The only quadrant where sine and tangent are both positive is quadrant 1. In fact, if we think about the other quadrants and why they wouldn't be the answer to this question, in quadrant 2, tangent is negative, so that would not work here because tangent's positive. In quadrant 3, sine is negative, so that wouldn't work here because sine is positive, so it can't be in quadrant 3. And in quadrant 4, both sine and tangent have to be negative. So the only quadrant where sine and tangent are both positive is quadrant 1. I'm fairly certain that that is the end of these notes. And it is taking a long time to decide to show me that. Yep, that's it. Okay, so that's the end of lesson 5-4.